Hello, Math 3 students. So today we're going to be going over undefined values. So what is an undefined value? It's going to be a value that makes the denominator of the expression equal to 0. We all are aware that in math you cannot divide by 0. So if a value makes the function such that you are dividing by 0, that would be an undefined point at that value. All right. So essentially what we have to do is we have to factor the denominator and set it equal to 0, okay? Whichever x values we get, those are the x values for which the function is going to be undefined, okay? So factor the denominator, set it equal to 0, you get your undefined values. So for this guy right here, you could factor, right? We could take a 6 out, and we get x plus 7 equals 0. You can't set 6 equal to 0. 6 just doesn't equal 0. You would do x plus 7 equals 0. You get x equals negative 7. So which values of x is the expression undefined? It would be undefined for x equals negative 7. All right. Then if we go ahead and take a look here, we can't factor this denominator at all. All right, we've got 8x plus 9. So all we have to do here is just set it equal to 0 and solve. Divide by 8. We get that x equals negative 9/8. So that would be another, well, for this function, that would be the value for which x is going to be, or the value of x for which the function is undefined. All right. Now let's go ahead and try this one. Now this one, it's a trinomial. So first thing we look for is a GCF. There is no GCF here in the denominator, so we just need to figure out what multiplies to negative 3, adds to negative 2. So we're going to do x minus 3, x plus 1. All right, and then after we factor, we can set each of our factors equal to 0. We get 3, and we get negative 1. Okay, so this function is going to be undefined at 2 spots. Here we can do the same thing. Again, we're going to take the denominator, set it equal to 0, figure out what multiplies to this guy, adds to this guy. Again, always look for a GCF. In this case, we don't have one. So we're going to do, let's see, x plus 9 and x minus 7. That's going to multiply to negative 63, add to 2. We set these equal to 0. We get negative 9, and we get 7. So this function is going to be undefined at x equals negative 9 and x equals 7. All right. So now, basically what we've done so far is we've just talked about how to find undefined values. Now, there's 2 types of undefined values that we're going to be dealing with. One is going to be a whole, all right? And then the other is going to be an asymptote. So, basically, the first thing you're going to do is look for a whole. And you know you have a whole when you have, let's see, they occur when the numerator and the denominator have common factors related to undefined values. So, essentially what that means is that if you have the same factor on the in the numerator and in the denominator, you're going to have a whole there, okay? So what this means is that we need to actually factor the numerator and the denominator, all right? So let's take a look. In the numerator here, we've got a difference of squares, all right? We can take the square root of both of these. We're going to do x plus 10, x minus 10. Now, in the denominator here, before I factor, I'm going to want to take out a GCF. Okay, so we take a 2 out. I get x squared plus 5x minus 50. Whoops. All right, so then I can factor that a little bit further. I do 2, x plus 10, x minus 5. Okay, now this function here is going to be undefined at both x equals negative 10 and x equals 5, right? Because if we take our denominator and we set it equal to 0, we're going to get negative 10 and 5. However, they specifically asked for wholes. Now, wholes are going to occur when you have a factor in the numerator and in the denominator, all right? Essentially what happens is these two guys cancel out, okay? But we can't ignore them because it represents a whole, okay? So this guy is actually going to have a whole at x equals negative 10, all right? So again, you have a whole when a factor from the numerator cancels with a factor from the denominator, all right? Let's go ahead and try this next one. So again, we got to make sure that we factor everything. So let's take a 3 out of here. We get x squared minus 3x minus 2. So our numerator is going to be, oh, it should be a plus 2. I'm looking like this isn't going to factor. My bad. All right, so this is going to be x minus 2, x minus 1. Those multiply to 2. Add to negative 3. Then we got to factor this guy. We're going to get x minus 8, x minus 1. All right. So looking here, right, we're going to have undefined values at x equals 8 and x equals 1. However, only one of these is a whole. If we look here, the factor x minus 1 is both in the numerator and the denominator, so we have a whole at x equals 1. All right. Next, let's go ahead and try this next one here. All right. So we'll go ahead and we're going to take out, we can factor the numerator quite easily here. We've got 2x minus 5, all right. Now, of course, we want to look and see if there's a GCF here, and unfortunately, there's not. I can't take a 5 out of 51, so that's where we got to go and do that AC factoring, where we're going to multiply here, and we get a 50, all right? So we've got to figure out what's going to multiply to 50, add to negative 51. So we're going to do negative 50 and negative 1, right? Those are going to multiply and give us a positive 50, add to negative 51. So we're going to go ahead, 5x squared minus 50x minus x plus 10. Again, remember you're just rewriting this minus 51 split into those two terms that we just found. Then we got to go ahead and pull out a GCF. So if we look at this 5x squared minus 50x, we're going to want to pull out a 5x there. And we end up with x minus 10. And then we look here, we're like, oh, we're so darn close. The signs are just messed up. So how about let's pull out a negative 1. So we end up with x minus 10. All right. So then these two guys out in front are going to become our first binomial here. So we get 5x minus 1 times x minus 10. All right. So we've just factored this denominator here to be 5x minus 1 and x minus 10, okay? So now, if we're looking here, we know that this function is going to be undefined at, and then remember, to find the undefined values, you have to take the denominator and set it equal to 0, all right? So when we do that, we get 1/5, and we get 10. Now, of course, we got to go look, okay, are either of these wholes? And neither of these guys are wholes. So while this function is going to be undefined at these two locations, there are no wholes here. All right, now, not all functions are going to have wholes. All right, let's try this next one. Again, we got to factor our numerator here. So we look and we say, okay, can we take out a GCF? Unfortunately, we cannot. So we're going to go ahead and do our AC factoring method. We get 10. So we need to figure out what multiplies to 10, adds to 11. That's going to be nice and easy. So we do 2x squared plus 10x plus x plus 5. Again, remember, we're just rewriting 11x as two terms. Then we're going to go ahead and take out our GCF here, which is going to be a 2x, my bad. And then we get x plus 5. And then this guy, there really isn't a GCF you can take out. And it's already the value we want it to be. So we could just take a 1 out. All right. So we end up with 2x plus 1, x plus 5. All right. So on the top, we get 2x plus 1 times x plus 5. And then in the denominator, we're just going to take out our GCF here, which is just a 3. All right. So this one is going to be undefined at x equals -5. And that is, in fact, a whole. How do I know it's a whole? Well, these two factors cancel from the numerator and the denominator, which indicates a whole. All right. Okay, so now there is another kind of undefined value. If it cancels out in the numerator and the denominator, it's a whole. If it is only in the denominator, meaning it's only in the bottom, that's going to be an asymptote, okay? So they occur when a factor is only in the denominator and not in the numerator, okay? So, again, we still need to factor the numerator to make sure that it doesn't cancel, because if it cancels, it's not going to be an asymptote, it's going to be a whole. So we can't do much with our x minus 10 on top, but we could take a 2 out here on the bottom. All right, so we know that this guy is going to be undefined at x equals -5, all right? And this guy, this x plus 5, doesn't cancel with anything on the top. If it canceled, it would be a whole. It doesn't. So we have a vertical asymptote at x equals -5. All right. Let's try this next one. So again, we got to factor the numerator. That's going to be x plus 10, x minus 9, and then we factor the denominator by just taking a GCF out. All right, so this guy is going to be undefined at x equals 9. However, that's a whole there. So there are no vertical asymptotes. All right. This 2, you can't make 2 equal to 0, right? It just doesn't work. If it was 2x, you could make it equal to 0. But if it's just a 2, it doesn't do much for us. All right, let's try the next one. Again, we have to factor our numerator here. Unfortunately, there's no GCF, so we got to go do AC factoring here. So we get a -12. So we're going to do 2x squared. And let's do minus 4x plus 3x minus 6. All right. So we're going to take a 2 out, and we're going to take an x out as well. And we get x minus 2. And then we can take a 3 out, and we get x minus 2. So we're going to have on top there 2x plus 3 times x minus 2. And then in the denominator, we can take a 2 out here, so we get x plus 7, 2 times x plus 7. All right. So we are going to be undefined at x equals -7. And x equals -7 does not cancel out with anything on the top, which means that it's not a whole, which means that it's going to be a vertical asymptote. All right. Last one. So again, let's factor the numerator here. This is going to be a GCF one. I could take a 3 and an x out. So I get x minus 4. And then on the bottom, another GCF, I can take my 5 out, and I get x minus 4. So we are going to be undefined at x equals 4. That does cancel with something in the numerator there. We have an x minus 4 on top and the bottom. So that means that we have a whole at 4. So that means because there's nothing else in the denominator, we have no vertical asymptotes. We have a hole at 4, but it's not a vertical asymptote.